Hello dear students, I am Surendra Jain, Master Teacher of Mathematics in Vedantu. In this session, I am discussing High Weightage Test 12, most incorrect questions done by the students. This test was based on linear equations in 3 variables. Okay, so let's discuss these questions. So this is a question where 3 equations are given and we have to find the condition on lambda so that it does have unique solution. It does have unique solution. So dear students, there is one important relation when unique solution is there, that determinant formed by the coefficients lambda 2 minus 2, 4, 2 lambda minus 1 and 6, 6 lambda. This determinant should not be equal to 0 if we want unique solution. If no solution or infinite solution, then this determinant becomes equal to 0. Now dear student, this will be some equation like quadratic or cubic or linear. When you equate this to 0, you will be getting some finite values of lambda. Okay, but we want d not equal to 0, so only those roots, let's say alpha, beta, gamma, or maybe alpha, beta only, or maybe alpha only. So those roots, if lambda not equal to, we will be getting unique solution. So your answer should be only one value, which 1 or 2 or 3 values which lambda is not equal to get unique solution. Now you can see all options are given as not equal to only. So from that we cannot eliminate any of the option, but if some option would have given like lambda equal to 2 or lambda is equal to 1, I think this will definitely be not answer, because unique solution will be there for infinitely many values of lambda. Not unique solution will be for just 1 or 2 or 3 values of lambda. So this can help you to eliminate some of the options, but here we cannot do it because options are given very cleverly, you can say. But here we will be solving it and we will find which lambda value is going to satisfy this d not equal to 0. Now dear students, one of the method is that you open it directly or you apply some properties. I will like to give you one hint that if you put all the values one by one, you will see if you put lambda is equal to 2, your first column becomes identical to second column. Lambda is equal to 2 will make you these two equal, these two equal, and these two equal. That means this determinant will become equal to 0 for lambda is equal to 2. So if lambda is not equal to 2, chances are that this will not be equal to 0, provided some other roots are not there, which we will have to check. So very first it looks like C will be the answer, but if you are not able to identify, then also it is okay. We will be opening it directly, or if you have understood that lambda equal to 2 makes these two column identical, then the best method would be that you subtract column 1 from column 2, and then you can see this will become lambda minus 2. Okay, this will become 4 minus 2 lambda. So from these elements of column 1, we can take lambda minus 2 common. Please check and see it very clearly. So lambda minus 2 common, so this will be 1, this will be minus 2, and this will be 0 here. Then it is 2 here, and this is 2 lambda here, and this is 6 here, this is minus 2, this is minus 1, and this is lambda here, and that is equal to 0. Now we can use further properties or we can open it directly, it's your choice. Maybe that property which we can use it, that you add row 1 2 times row 1 to row 2. Okay, so if we do that thing, let me do it here. Okay, what I am going to do, R2 I will be adding by 2 times R1. Okay, so in that case it will become lambda minus 2 into, this will be 1 2 2, no change in row 1, row 2 this will become 0, this will become 2 lambda plus 4, and this will become I think minus 5. 2 times of this added to this, so minus 5, and this will be 0, this is 6, and this is lambda. Okay, so if you open it along first column, we will be getting 2 lambda plus 4 into lambda, so 2 lambda square plus 4 lambda, and minus minus plus 30. Okay, now dear student, this need not to be 0. Here this is a quadratic and you can check its d is negative, so its root will be imaginary, so it will be never ever 0. So only value which can make this expression equal to 0 is 2, and which we do not want. So the only option for this will be lambda not equal to 2. So that is the method for this question. Dear student, there can be one more method, but that other method will not be so easy for this particular question. I will like to give you the idea how this is done. Please see what we will be doing. We will put value of x and y in terms of z using these two equations. Okay, so what I will be doing, I will be let me write this equation: lambda x plus 2y minus 2z is equal to 1, 4x plus 2 lambda y minus z is equal to 2. Now if I want to know the value of x in terms of y, what I will be doing, I will multiply this by lambda. So when you subtract, y term will cancel and we will be getting lambda square minus 4 into x, and that will be equal to for this z term will be 2 lambda minus 1 on the other side, okay, and plus lambda minus 2. This will be with z also. Okay, so we got x in terms of z. I will write z into z into 2 lambda minus 1 plus lambda minus 2 whole divided by lambda square minus 4. Similarly, we can find y also. We can find y also in terms of z into some bracket plus some constant in terms of lambda, you can say, and upon some bracket here. I am not doing with this method because for this question particularly this method is not that better, but I am still giving you the idea. Okay, so x is this, y is this. Now we will put x and y in terms of this z and lambda in the third equation. So after simplification, we will be getting z into some expression which will be in terms of lambda and equal to expression 2 that will also be in terms of lambda. Now dear students, if expression 1 is not equal to 0, then a unique value of z will be obtained, and for that unique value of z we will get unique value of y and unique value of x. So that will be the condition for unique solution. So you just need to make this expression not equal to 0, but you will find this is exactly same thing that we obtained in method 1 by calling d not equal to 0. So this method is not better for this particular question, but it will be better for some other question. That's why I am telling you this in this question also. Dear students, if this is equal to 0 and this is not equal to 0, okay, this is 0, this is not equal to 0, you can see this will be 0 but this is not equal to 0, so no solution scenario. So if this is the scenario, no solution. If this expression is equal to 0 and this expression is also equal to 0, then you will have infinitely many solutions. So this can be the method for all scenarios: unique solution, infinite solutions and no solutions. Okay, so this is how this question can be done. I think I will suggest only method 1. So answer was, I think answer of this should be C, not A. I think they have made some error in this. It will be rectified. In fact, in the solution lambda not equal to 2 is given. Coming to this question, here we are given 3 equations, but not in terms of x, y, z, but in terms of x square, y square and z square. If you look at these equations, you will find that x square is equal to a square, y square is equal to b square and z square is equal to c square is satisfying these 3 equations, because this will make x square equal to a square will make this as 1, y square is equal to b square will also make it as 1, z square upon c square will also make it as 1. So this is satisfied for these values, this is also satisfied for these values, and this is also satisfied for these values. But dear students, can we still say it will be having unique solution or finitely many solutions? Maybe this is one of the solution, so no solution case is gone, but unique solution or infinitely many solutions or finitely many solutions can still be there. So for that we need to check for D. Okay, so what I will do, dear students, please listen carefully. I will be writing x square upon a square as capital X and so on. So your equations would be capital X plus capital Y minus capital Z is equal to 1. Similarly, capital X minus capital Y plus capital Z is equal to 1. Here minus X plus Y plus Z is equal to 1. Now this will be now easier to solve, because your D is just, I think, 1, 1, minus 1, 1, minus 1, 1 and minus 1, 1 and 1. Okay, it can be easily checked if you add last column into first column and second column. So this will make 0 here, this will be 2 here, and this will be 0 here. I think nothing else is needed, only one column if you add, that is also giving you 2 zeros in one row, one column, so that is sufficient. So 1, 1, 1, minus 1, 1 and 1. If you expand along column 1, I think this value is coming out to be not equal to 0. So this gives you the impression that there will be a unique solution, and the unique solution we have already obtained here. Okay, but dear students, please understand very carefully that if x square is equal to a square, that means x can be plus a or minus a, y also can be plus a or plus b or minus b, and z can also be plus minus c. Now if I keep writing all these values, x can be chosen in 2 ways, y in 2 ways, z in 2 ways, so total 2 into 2 into 2, that means there will be 8 solutions. There will be 8 solutions, taking this as a, b, c, then a comma b comma minus c, a comma minus b comma c, etc. So there will be total 8 solutions. So answer for this will be finitely many solutions. See, in our theory of this kind of questions, we read either unique solution or no solution or infinitely many solution. There is no scenario where finitely many solutions can be there, but because this is not a linear equation in x, y, z, it is linear equation in x square, y square and z square. There we are definitely getting unique solution, but if you write in terms of x, y, z, we are getting finitely many solutions. So please be careful. So that is one of the method. Second method also I will like to discuss here, and the second method would be that suppose you are not able to identify that x square is equal to a square and y square is equal to b square and z square is equal to c square is one of the solution. So in that case I will suggest write same x square upon a square as capital X as I did in my method 1, that I will again suggest here, otherwise your calculation will be more. So this will be capital X plus capital Y minus capital Z is equal to 1, capital X minus capital Y plus capital Z equal to 1, minus capital X plus capital Y plus capital Z is equal to 1. Now dear students, if you are having a unique solution, Cramer's rules tell you the value of x, y and z. This is given by dx upon d. Similarly, y is dz upon dy upon d, and z is dz upon d. So this is how we find these solutions, and how these dx, dy, dz are found. To find this, I think d is just the determinant obtained by coefficient, which is 1, 1 minus 1, 1 minus 1, 1 and minus 1, 1 and 1. I think we have found this determinant in the last method also. This will be coming out to be 2 into 1 minus plus. So I think minus 2 it will be. This will be minus 2 because this 2 is a 2 1 element, and if you expand along column 1 it will be 1 plus 1, so 2, and multiplied with 2 will be giving you 4, sorry, so it will be minus 4 here, it will be minus 4. Okay, so the value of this determinant we are getting as minus 4. Now then we will be finding dx, I will be only finding dx, dy and dz can be found similarly. Now to find dx, we need to replace first column of this determinant by the constants, which is 1, 1, 1. So the remaining column will be same, 1 minus 1, 1, and this is minus 1, this is 1 and this is 1. Now in this case we can add last column to first two columns. Okay, so it will become 0 here, this will become 2 here and 2 here. If you add this column with the second column, this will be 0 here, this will be 0 here, and this is 2 here, and this is minus 1 and this is 1 and this 1. Okay, so what is the value we are getting? We can expand maybe along first row, so minus 1, okay, minus 1 multiplied with, it will give you 2 into 2, 4, so this is coming out to minus 4 only. So from this you can see dx is 4 and d is also minus 4, dx is minus 4, d is also minus 4, so x will be equal to 1. So same answer we are getting for this x square equal to a square. Okay, we can find dy also and dz also by replacing this constant values 1 1 1 in second column in the D, and for dz in the third column of this D will give you dy and dz also. From there we can check these x, y, z all are coming as 1 1 1 because I have taken this as capital X. So solution in terms of x square will be a square, in terms of x it will be plus minus a. So dear student, answer for this will be finitely many solutions. Now this question says the value of lambda and mu for which the system of equation have unique solution. So for unique solution we know the D has to be not equal to 0, which is 1 1 1 from coefficients, then 1 2 3 and 1 2 and lambda. So dear students, because there is only one place where lambda is appearing, so if this is not equal to 0, it will be some linear. So whatever this linear is coming out to be, the 0 of that linear, if you find and make it not equal to 0, will give you the condition of unique solution. There has to be no restriction on mu, because once you have made D not equal to 0, it will be having unique solution. So in my opinion, you can directly say the answer can be A, because if you are saying mu equal to 10, there should not be restriction on mu. Why not mu can be 10? Why not it can be 20, 30? It can be anything actually. So all the options are wrong, only A option is correct. You can check after opening this determinant that it will be coming out to be some constant into lambda minus 3, and making it not equal to 0 will give you lambda not equal to 3. So that is one method. I will like to give you one more method of this question, dear student, and that method is, we will be writing these two equations. First two equations, x plus y plus z is equal to 6, x plus 2y plus 3z is equal to 10. Now if you write x and y in terms of z, if I subtract first from the second, I think we will be getting y plus 2z is equal to minus 6. Sorry, this was 10 actually. So if this is 10, this will be equal to 4. This will be equal to 4. We are subtracting first from the second. So y plus 2z is equal to 4. So y is equal to 4 minus 2z. Now if we write similarly x in terms of z, for that I will need this to be multiplied by 2 and then subtract second from first, will give you x minus z, because y is cancelled, 2z minus 3z is minus z, is equal to 2. So my x will be 2 plus z. So this is y and this is x in terms of z. Now we will put x and y value in the third equation. The third equation now will become 2 plus z in place of x plus 2 into y. So it will become 8 minus 4z for 2y plus lambda z is equal to mu. In this case, z if you add, it will become lambda minus 3 into z. Okay, and all the constant on the other side will be, I think, mu 2 plus 8 10, so mu minus 10. So dear student, after knowing this equation which we obtained from 1 2 and 3, let me call this as 4. Okay, now if this is not equal to 0, you will be getting a unique value of z for every value of mu. So that's the reason why for lambda not equal to 3, it will be having unique solution. Your mu can be anything. Suppose this question was also asking you infinitely many solutions. So infinitely solutions will be only if this is 0 and this is also equal to 0. So if lambda is equal to 3 and mu is equal to 10, will give you infinitely many solutions. If this is 0 but this is not 0, then it will be condition of no solution. Here we are asked only unique solution, so answer is A. So the second method can be easier in case you are not very comfortable with solving the determinants. In fact, in Cramer's rule, you need to solve 4 determinants. If you are looking for infinitely many solutions, no solutions, you need to solve 4 determinants. So if you want to avoid that, this method 2 can be there. Now coming to this question, where we are given 3 linear equations and we are asked when it will have no solution, infinite solution or unique solution. So first of all, we should know what is the condition of unique solution, no solution and infinitely many solutions. So first of all, we define a D determinant created by the coefficient. Like here it will be lambda 2, 2, 2 lambda 3 and 5. This will be 4 lambda and 6. Okay, so if this d is not equal to 0, then we get unique solution. There is no other condition required for unique solution. Just one solution, unique solution for this thing. If this d is equal to 0 and simultaneously dx, dy and dz, they are also equal to 0, then we get infinitely many solutions. Infinitely many solutions. But dear students, there is one exception. What is that exception? Please listen carefully. If your coefficients of x are a1, a2, a3 and their ratios a1, a2, a3 are same as coefficients of y, that is b1 ratio b2 ratio b3, and similarly for z, this is equal to c1 ratio c2 ratio c3. That means this ratio here, here, this, they all are in equal proportion, which means they will be representing three parallel planes. Now if right side numbers like 5, 8, 10, they are not equal to, they are not having same ratio which a, b, c are having, then it will still having d, dx, dy and dz equal to 0, but we will be getting no solution. Okay, that is second condition. And the third one is that d is equal to 0, but at least one of dx or dy or dz is not equal to 0. In that case, it will be having no solution. It will be having no solution. So you can see the no solution scenario can be two times, one here with this exceptional case and one this case. Now first let us try to find unique solution condition here. So dear students, if you open this determinant, I think you can apply some properties like make this 2 lambda 0 if you multiply row 1 by 2 and subtract r2 from r1, and then you open it. I think finally you will be getting lambda minus 2 into lambda plus 8 not equal to 0 for unique solution, which means lambda will not be equal to 2 and lambda will not be equal to minus 8. So in this option D, where they are saying lambda is equal to minus 8 giving unique solution, is wrong. Okay, so this option is wrong. Now coming to infinitely many solutions. So for infinitely many solutions, we will be checking for dx, and dx is nothing but you place these constant terms 5, 8, 10 in first column and then 2, 3, lambda, 2, 5, 6. Actually dx is always created by replacing first column of d by these constant term. These two column will remain same. Okay, if you expand it, I think this comes out to be 34 minus 9 lambda. Okay, now dear students, this will be 0 if lambda is 34 by 9, but if I look at these numbers here, I think lambda is equal to 2 will make it not equal to 0 when lambda is equal to 2. So this will be the correct answer of this question. This was already wrong. In fact, in one of the options they have given lambda is equal to 2, then infinitely many solutions, so this is also wrong. Dear students, I think there is some problem in this question. C also seems wrong, because if lambda is equal to 8, okay, lambda is equal to 8, actually, okay, no, it is fine. Actually lambda is equal to 8 means your d will be not equal to 0, so this will be having unique solution, so this is also wrong. Actually lambda is equal to 8 will give you d not equal to 0 because d is given by this, so this will give you a unique solution. So I think, yeah, this is correct. So A option is correct of this question. Now coming to this question, where we are given system of 3 linear equations are having no solution, unique solution, many, infinitely many solutions for which values of alpha and beta. So in this question they are asking not true first of all. So the very first thing I like to tell you the theory, that if d, that is obtained by the elements which is obtained by now coming to this question where we are given 3 linear equations and we are asked when it will be having no solution, unique solution or infinitely many solutions. So the theory first I like to tell you, the theory here is, if your d, the determinant obtained by the coefficients, that is 1 1 1, alpha, beta, 7, 1 2 3. If this is not equal to 0, we get a unique solution. We get unique solution. Let me do this question also simultaneously. If you simplify it, you will be getting minus alpha plus 2 beta minus 7 not equal to 0 for this D to be giving you unique solution. Now first option, B option says if alpha is equal to beta and alpha is equal to not equal to 7, if alpha is equal to beta, these two will give you alpha only, and if alpha is not 7, this will be not equal to 0. So this will give you unique solution. So this seems true, but this is not correct option. Okay. Now second thing, if D is equal to 0 and dx, dy and dz, they all four are 0, then we get infinitely many solutions, but there is one exception, dear students, because without giving you that exception, this statement will be wrong. And that exception is that if your coefficients of x are, let's say, a1, a2, a3, so their ratios a1 ratio a2 ratio a3. Similarly, ratios of coefficients of y, which is b1, b2, b3, and similarly coefficients of z, c1, c2, c3, they all are equal, but they are not equal to the ratio of constants on the right hand side. So a1, a2, a3, ratio b1, b2, b3, ratio c1, c2, c3 not equal to d1 ratio d2 ratio d3. In this case, these equations becomes equations of three parallel planes, so they will never ever intersect. But in this case, you will see d, dx, dy and dz, all four becoming equal to 0, but still you will be having no solution, so that's one exceptional case. Please take care of this thing. Now third scenario means case when D is equal to 0, but one of dx or dy or dz is not equal to 0. In this case, we will be having no solution. So let's now try to find out the case of infinitely many solutions. First thing I like to tell you that the first plane and third plane, they are not parallel, so this exception case cannot happen in this case. So we will be just checking for dx, and dx is, you put the constant terms which are 6, 3 and 14 in the first column, 6, 3 and 14 in the first column, and keep those two columns as it is, 1 beta 2 and 1 7 3. Okay, so if this become equal to 0, similarly dy and dz also becoming equal to 0, along with d equal to 0 will give you infinitely many solutions. So in this case, if you simplify it, I think we will be getting this as 4 beta plus 11 equal to 0 will give you beta is equal to minus 11 by 4. Similarly, if you make dy is equal to 0, we get, I think, minus 4 alpha minus 50 is equal to 0. That gives you alpha is equal to minus 25 by 2. Okay, I think these two values will make dz also 0. You can check at alpha is equal to minus 25 by 2. And but dear students, there is a calculation involved which you have to do very carefully. Dz will also become equal to 0 when alpha is this, beta is this. So if this is value of alpha, this is value of beta, all dx, dy, dz will become equal to 0. And also you can check this d, because minus alpha plus 2 beta minus 7 need to be 0 if we are looking for infinitely many solutions. So this minus, actually this is with minus sign, so 25 by 2, and this will be minus 11 by 2, so 25 minus 11 is 14 by 2, so 7 minus 7 0. So this alpha and beta is making all d as 0. So these values, only these values will give you infinitely many solutions. So let us see what are they saying for infinitely many solution. There is a unique point alpha beta on the line x plus 2y plus 18 for which system has infinitely many solutions. So dear students, this point if you check is satisfying this equation also. Minus 25 minus minus 25 minus 11. So this is minus 36 upon 2, 18 plus 18, 0. So that's the only point on this line for alpha beta which will give you infinitely many solutions. So this is also true. Okay, for every point alpha beta not equal to 7 comma 7 on the line x minus 2y, I think this line is coming from this equation. The system has infinitely many solutions. I think this is wrong because we have proved that only these two values, this value of alpha and this value of beta, will give you infinitely many solutions. So this is false. Okay, one more option we have given, we are left with alpha is equal to beta is equal to 7, then system has no solution. So dear students, if alpha is equal to beta is equal to 7, I think you will be getting no solution. I think that's correct, because for infinitely many solutions we are having this condition. If we take alpha beta as this, your d will become equal to 0, your d will become equal to 0, but dx will not be 0, dy will not be 0. So this is also giving you a true statement. So true, 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 and this is false. So the correct answer of this should be D. Okay, I hope I have made this question bit clear. We started with d not equal to 0 for unique solution, then for d equal to 0 and dx, dy, dz equal to 0, we found condition of alpha and beta being minus 25 by 2 and beta is equal to minus 11 by 4. So that's the only value of alpha beta that gives you infinitely many solutions. So only this option is false, all other are true. Okay, now I will be giving you another method, alternate method for this question. This alternate method is better when your equations are such that coefficients are mostly known. Like here all the coefficients of x, y, z are 1, 1, 1, and here also 1, 2, 3. So in this case what we will be doing, we will write x and y in terms of z, and this x plus 2y is equal to 14 minus 3z. If you simplify, okay, if you simplify them, I think we will be getting y as, you just subtract 1 from 2, you will be getting 8 minus 2z. If you multiply this by 2 and then subtract this from this, we will be getting x is equal to, I think, minus 2 and plus z. Now if you put these values of x and y in this middle equation here, we will be getting alpha into minus 2 plus z plus beta into 8 minus 2z plus 7 into z is equal to 3. So we will be getting coefficient of z as, I think, alpha minus 2 beta plus 7, and the constant term will be 2 alpha minus 8 beta plus 3. Now dear students, if this is not equal to 0, whatever this is, you will be getting unique value of z. Now you can compare with this condition. I think this is same condition here also. If alpha minus 2 beta plus 7 is not equal to 0, will give you unique solution. If this and this both are 0, 0, that means alpha minus 2 beta plus 7 is equal to 0 and 2 alpha minus 8 beta plus 3 is equal to 0. The solution of this will be, I am sure it will be coming out to be alpha is equal to minus 25 by 2 and beta is equal to minus 11 by 4. Will give you infinitely many solutions. If this is 0 but this is not 0, will give you no solution wala case. So you can analyze, I think this is the only correct answer because all of them are true. So this is the correct answer because they are asking not true. Okay. Now coming to this question which says K belongs to R, then there exist non-zero solutions of the system of equations. Dear students, whenever we are given homogeneous equations like this, a1x plus b1y plus c1z is equal to 0. Similarly, a2x plus b2y plus c2z is equal to 0. a3x plus b3y plus c3z is equal to 0. Okay, obviously x is equal to 0, y is equal to 0 and z is equal to 0. They are a solution and this is called zero solution. Obvious name for this, also called as trivial solution. Trivial solution. Okay, but if we want other than zero solution, that means we are looking for infinitely many solutions. By the way, no solution case is not possible here. So here if D is equal to 0, sorry, not equal to 0, as we know for such equation this gives you a unique solution case. In this case, unique solution, that means only 0 0 solution, only 0 solution. But if D is equal to 0, then there will be infinitely many solutions, infinite solution, which will include 0 solution also and non-zero solution also. So non-zero solution, if we are looking for, the determinant created by the coefficients of x, y, z should be equal to 0. Now you can see first row will be 2k, 3 and 3. Second row, you please check 2y term can be clubbed here, so this becomes 0 here and the coefficient of y will be k plus 2 here. This will be 2 here and this will be 3 here. If you bring minus that here, this is 4, this is 2k and this is k plus 1. So this need to be equal to 0 in order this to have non-zero solutions. Okay, if we simplify it, I think the values we are getting are k equal to 1, minus 1 and 3. Okay, so for how many values we are getting non-zero solutions? I think 3. So A option is wrong. Exactly one negative value, so I think this is correct. Every value of k obviously wrong. Exactly one positive value, I think this is also wrong because we are having 2 positive values of k. So this is how this kind of questions are done. Very important category of questions and very simple also, I will say. No need to check for dx, dy, dz. Only D will tell you whether non-zero solutions or only zero solutions. Okay. Now coming to this question, this says identify the correct statement. The first statement is a system of n simultaneous linear equation has unique solution, then coefficient matrix is singular. Singular means the value of determinant equal to 0. I think this is wrong because determinant need to be not equal to 0 if we are looking for unique solution. So I think B option is true because it is having only this change here. So B option is true. All others should be incorrect if it is single correct question, but let's see. If A inverse exists, then adjoint of A inverse exists, may or may not exist. Okay, so dear students, adjoint of A determinant is actually equal to determinant of A raised to the power n minus 1. So if this determinant is not equal to 0, this will also be not equal to 0. Okay, and you know the condition for A inverse exists is determinant should be not equal to 0. So if this exists, this will definitely exist. So may or may not is wrong. Okay, now fx, I think simple question of matrix. If you multiply fx with fy, okay, fy means all x will be replaced by y, and if you multiply them, you can check this comes out to be f of x plus y and not f of x minus y. So this is also wrong. So the correct answer of this question is B only. Okay, that's it for this session. Thank you so much. Bye, bachcho. Take care.